The purpose of this video is to help you understand a few things about the lever lab that were confusing. They were mostly vocabulary issues, I think, more than issues of understanding the concept. But I wanted to make sure that everyone got this before we move on to the next simple machine. So first of all, from our textbook, mechanical advantage is the output force divided by the input force. And you can see if you have an output force that's greater than your input force, your mechanical advantage will be a number that's greater than 1. That will actually be an advantage. You're using a machine that's outputting more force than you're putting in, but you're still getting the same amount of work done. Another thing from the textbook is when you're working with a simple machine, the torque that you put in should equal the torque that you put out. The work that you put in should equal the work that you get out. And so in this problem, the rock, which is 3,500 newtons, is being moved 1 meter. So since work is force times distance, we're moving a 3,500 Newton force a distance of 1 meter. That's the amount of work that we're going to do. So that's the amount of work that we have to put in. So even though we're putting in that amount of work, just like earlier in the semester when we talked about using a ramp, you don't have to put the same amount of force in to get that work done if you're using a machine. So we have force in times distance in equals force out times distance out. That's just saying that the work has to equal the work. Now, this proportion right here is exactly the same thing as this line of this equation here. If you take this proportion and you think of cross multiplying, force in times distance in is what's on the left-hand side of this equation, and force out times distance out is what's on this side of the equation. This is an inverse relationship, and this is not a typo, but a lot of times students get this mixed up. Force out over force in equals distance in over distance out. And if we go back up to the mechanical advantage formula, force out over force in now also equals distance in over distance out. And we learned by doing the lab that there are 2 different ways of figuring out the mechanical advantage, and everyone answered that the mechanical advantage would be the same no matter which way you calculated it, by using the forces or by using the distances. So the first thing that we discover by doing this lab is that the maximum amount of force that Harry can generate is 3,000 newtons. And here's how you know that. If you put the distance, his effort distance right here, at the smallest amount possible, so I'm going to put it as low as I possibly can, and I tell him to lift the rock, it says that he generates 3,000 newtons of force, but the rock doesn't move. If I make this end of the lever a little bit higher, so he's going to push it down a further distance, he still generated 3,000 newtons of force, but that wasn't enough to move the rock because the rock is 3,500 newtons. So this is what we need to know. If the input distance is set at 1, so I'm going to change the input distance to exactly 1, then it matches the output distance, which is 1 meter on this problem because we're trying to lift the rock 1 meter off the ground. Therefore, the mechanical advantage, if we're doing the mechanical advantage formula using distance, is 1 meter. He's going to push this into the lever down, and the rock is going to go up 1 meter at this end. So the mechanical advantage is 1 over 1, which really isn't an advantage at all. So Harry might as well lift the rock without the lever. So the only thing that's changing here is Harry's able to redirect the force. So he's pushing down on this end and making the rock go up on that end. And that could help, but he doesn't really have a mechanical advantage. So if we let Harry try it right here, we know it's not going to work because he can only generate 3,000 newtons of force. The rock weighs 3,500 newtons, and his machine is not giving him any mechanical advantage because the mechanical advantage is 1. So now right here, if the input distance is set to less than 1 meter, then he actually doesn't have a mechanical advantage. It's actually a mechanical disadvantage. In this particular case, he's going to have to apply more than 3,500 newtons of force to lift the 3,500 newton rock. If we make the distance of the left end of the lever more than 1, then he will have a mechanical advantage because the input distance will be greater than 1 and the output distance will be less than 1. And so when we divide those two distances, we'll get a number that's greater than 1. We actually will have a mechanical advantage. He'll be getting out more force than he's putting in to do the same amount of work. So we can calculate exactly how high to put the left end of the lever so that with his maximum amount, his 3,000 newtons of force, he will be able to move the 3,500 newton rock. So here's our formula. The force out over the force in equals the distance in over the distance out. So the force output that we need is 3,500 newtons. That's how much the rock weighs. The input force is going to be 3,000 newtons because that is all the force that Harry can generate. The input distance is what we're trying to calculate. How high, what is this distance that he is going to move the left end of the lever down by pushing on it? And we already know the output distance because the requirement of our scenario is that Harry lifts the rock exactly 1 meter off the ground. So when we cross multiply, we get 3,000 times x is 3,000x, and we get 1 times 3,500, which is 3,500. Then we divide both sides of this equation by 3,000, and x, which is our input distance, is 1.17. So if we set the input distance, if we make sure that the left hand end of the lever is 1.17 meters high, and Harry applies his maximum 3,000 newtons of force, he should be able to lift the rock 1 meter off the ground. So we're going to set this to 1.17, hopefully. And we ask him to lift it. And for the first time, he's able to lift the rock. And you can see the amount of force that he had to use was 2,966 newtons of force. And so he lifted or pushed the lever down 1.17 meters with 2,966 newtons of force. And what he got out of the other end of his machine was he lifted the 3,500 newton rock 1 meter off the ground. So the distance here was 1.17, and the distance he got out was only 1. So there was less distance coming out of the machine, but the less distance coming out of the machine was made up for by the less amount of force that Harry had to put into the left end of the lever. If I change the height of the left end of the lever to, say, 1.11, now we know that with that height, if he pushes the left end down 1.11 meters, he's not going to be able to generate enough force on the other end to lift a 3,900 Newton rock. So Harry can't move the rock if he only has the left end of the lever 1.11 meters off the ground. So finally, if Harry doesn't want to work so hard, if he doesn't want to risk straining himself by using the maximum amount of force that he can generate, the 3,000 newtons, he can just get this end, the left end of the lever, as high as he possibly can off the ground, which in our example is apparently 2.13 meters. So this is 2.13 meters off the ground. So when he starts pushing it down to get it from where it is all the way to the ground, he's going to move it 2.13 meters. But the other end of the lever is going to go up only 1 meter. So he's moving it a lot further than the rock is actually going to move at the other end, but he's going to use way less than 3,500 newtons of force to get the work done. So it turns out if you put this end of the lever as high as you can get it, 2.13, then it only takes 1,651 newtons of force to lift a 3,500 Newton rock. Now that's what I call a mechanical advantage.